Today we're going to be talking about the definition of the derivative. And the definition of the derivative, this is our notation, f prime is what we call it, for the derivative is this limit. And that's the whole reason that we learn limits. And then there's two alternate definitions. This one we've talked about where it's really, if they give you a point, use this definition. And then there's another definition. Remember what that meant? That meant slope way back in Algebra 1. Okay, so our derivative means slope of a tangent line. It's our notation for derivative. And then just some delta x. Remember, delta x means change in x. You move x over a certain amount. Okay, so as I was just saying on the last slide, derivative stands for the slope of the tangent line at the point, at a specific point. Okay, so say we have a point here, let's call that x, and then we have another point here, let's call that a, and we look at the slope of the line through that point. Well, that's f of x minus f of a all over x minus a. But remember, we're looking for the slope of the tangent line, and I'll draw the tangent line in at point A. Would look something like that. So I need to bring x towards A. That's why it's a limit. And going back to this last slide, because I forgot to tell you guys something, make sure you know these definitions. This is a guaranteed quiz and test question. What is the definition of the derivative? It's one of these three limits. Versus the meaning of the derivative is the slope of the tangent line. Now our notation for derivative, okay, y prime. dy dx, the derivative with y with respect to x, where x is your independent variable. df dx, so derivative of some function, okay, or d dx of f of x. So all of these, you need to recognize that all of those mean the derivative with respect to x. Use one of the definitions of the derivative to find the derivative at point A. So since they give you a point, I would recommend that we use limit as x goes to a of f of x minus f of a all over x minus a. So, again, rewriting that, just because it's good for us to write it, because I'm going to want you guys to know this definition backwards and forwards. Okay, our a is -2. Our function is x squared minus 3x. When I plug in -2, we get a positive 10, so it's a minus a 10 all over x plus 2. Now you should recognize that when I plug in -2 on the top and bottom, that you get 0 over 0, so that's why we've dealt with all those limit laws, or basically finding limits by algebra. You have to factor, and I'll give you a hint that my calculus teacher told me. The top is going to factor so that the bottom cancels out. So that now the x plus 2's cancel, and we can now take our limit as x goes to -2 of x minus 5. Plugging in -2, we get a -7. Use one of the definitions to find the derivative at any point. When you're doing any point, I recommend you do the h goes to 0 of f of x plus h minus f of x all over h. Now, okay, so we have the limit as h goes to 0 of f of x plus h. So I plug in x plus h wherever I see an x. minus f of x is just your regular old function, all over h. Now, you need to simplify that, because if you plug in 0 on the top and bottom, you're going to get 0 over 0. So you need a common denominator on the top. So I need to multiply this top fraction by x plus 1 over x plus 1. So I have x plus 1 over x plus 1 times x plus h plus 1. I need to multiply this by the denominator there. So simplifying, and I'm not going to talk through my simplifying here. Well, I guess I could talk through it. Basically, these denominators go with the h in the denominator. On the numerator, we have x plus 1 minus x minus h minus 1. So now notice how on the numerator a few things cancel. The x's cancel, that cancels. So I'm left with the limit as h goes to 0 of a negative h over an h times an x plus 1 over an x plus an h plus a 1. That cancels to become a 1. So now I can plug in 0 and get negative 1 over x plus 1 times x plus 1, or negative 1 over x plus 1 squared. Now notice what I did, something I want to highlight. Make sure you realize that I have these limits here. I've carried my limit through, and I did on the last problem, until I plugged in the value where I was actually taking my limit. Okay, right-sided derivative. So finding your right-sided derivative, so if you have like a piecewise function like we're going to have in the next example, okay, right-sided for numbers a little bit more, you just basically take the derivative for the values a little bit more, and left-sided is for the values a little bit less. So it's really the same thing we were doing. Okay, so show that the function has a left side and, oh, I didn't fix that, right side derivatives at 1, but no derivative at that value. So, okay, so let's do our left side. So the limit as h goes to 0 from numbers a little bit less. Numbers a little bit less is this function up here. X plus h minus f of x all over h. Okay, so the x's cancel, and I can factor out an h, so that now those h's cancel, so I'm now finding the limit as h goes to 0 from numbers a little bit less of 2x plus h. When I plug in 0, I get 2x. So that's for any point. But I need to find that at 1, so I plug in 1, and I get 2. Now, I didn't think about it. I could have used that other definition if I wanted. For some reason, I just chose to use the x plus h one. That's the one I'm really used to using. Okay, now let's do the right side derivative. Let's do the right side derivative with the other definition. Doesn't matter which definition you use. Okay, so f of x. I wrote my notation wrong. Actually, no, I lied to you. Marnell, get with the program. I flipped back because we defined it with that definition. So I have to use my h goes to 0. Get with the program. Okay, so f of x plus h minus f of x all over h. Okay, so going through and simplifying. And this is what takes so much time a lot of times in these videos. I assume that we are all good simplifiers, but it's often stated that in calculus this is what kills you. Okay, the 3x's cancel. The h's cancel. So I'm finding this. So my slope at any point is 3, which makes sense because what's the slope of that line? The slope of that line is 3. So my left side derivative worked. My right side derivative I was able to find a value, but they weren't equal. Since my derivatives from the left and right aren't equal, then we cannot find the derivative. Highlighting what we're going to do in a future section, limit as x goes to 1 from numbers a little bit less. You use that top function, and we get the value of 1. Limit as x goes to numbers from a little bit more of 1, we use the bottom function, that's 3. We know if the limit doesn't exist, our function is not continuous. So therefore, if your function's not continuous, then you're not going to be able to take the derivative. And we're going to highlight that in a future section. Okay, please for me, make sure you get that form filled in online.